So very short intro on my side. So my name is Antoine. I am ecosystem lead at Argent. So that basically means that I am your go-to guy, your point of contact for everything related to Argent's products. But we are also very keen at Argent to help grow the zkSync ecosystem. So very happy as well to discuss co-marketing, co-organizing of events, these kinds of topics. So don't hesitate to have my contact there at the bottom of the slide, so you know where to join me. And then, well, today we're going to have a very concrete deep dive on how to make a dapp compatible on compatible with account abstraction on zkSync era. And this demo is going to be given by Axel, who's also from Argent. So, Axel, in 2 sentences.
Yeah, thanks, Antoine. I'm Axel. So I'm working on everything related to blockchain at Argent, with a specific focus on everything zkSync, the smart contracts, everything account abstraction, of course, and some things regarding the SDKs and the infrastructure around this. So, of course, we're very excited by the recent ERA launch, and our ERA account, a smart account, is currently being audited and going through a slow release. Hello?
Yes. Thanks a lot. Thanks a lot. So yeah, this workshop is also co-organized with as you know.
Hey, Dobie, I'm gonna mute you.
Awesome, okay. Thanks. So the workshop is co-organized with Matter Labs. They won't come on stage now, but if you have any question related to zkSync era, also don't hesitate. They will be able to jump in and answer them. If you have more, precise questions or complex questions, you can also simply email them to isha@matterlabs.dev. Now, I don't want this session today to just be a presentation. I would like really to have something interactive, some kind of discussion. So if you have questions or you want to say anything, you want to say GM or anything, just don't hesitate. There might be a button, to raise your hand. If it's not the case, just, you can interrupt. I won't mind. You can also ask for questions in the chat. I will make sure that we answer all of them by the end of the session. Originally I wanted, to have a round table so that everybody could present itself and tell us what they're building on zkSync era and why zkSync era. But actually, we have more participants than first expected. So because of timing, we won't be able to do that. But still, I have built this slide so you have an idea of who's in the audience. As you can see, it's a very diverse audience. We have people here coming from, centralized exchanges, decentralized exchanges, some wallets, all kinds of dapps, mainly in, I would say, gaming, in DeFi as well, some in infrastructure. So very, very interesting crowd today. Now, as you might have noticed, account abstraction has been in the spotlight quite a bit in the past weeks, and that's mainly thanks to ERC-437, which has been implemented on Ethereum mainnet, as you might know. And I just want to, touch base and make sure that everybody really understand what ERC-437 is and what is its impact on account abstraction. So the question is actually, why is there still no full account abstraction on layer 1, right? And the answer to that question basically boils down to 3 elements. The first one is that on Ethereum layer 1, only EOAs can initiate transactions, right? Because at the onset of the network, it was deemed that smart accounts would actually belong to smart contracts and not to end users. And so they would not be able to initiate transactions. The second reason is that Ethereum is, as you know, expensive. That's a problem. And that's even more so a problem when you use a smart account because of all the built-in logic. Transactions are even more expensive. So it's an issue now, and it makes it almost unusual in a bull market, I would say. And then the third reason is that on Ethereum layer 1, smart accounts are second-class citizens. So that is, of course, related to point number 1. but it's also the fact that transactions coming from EOAs and from smart accounts will follow two different flows on Ethereum, and so dApps usually built only for one of these flows, and that's of course a big barrier to a wide adoption of account abstraction on Ethereum. Now, what does ERC-4337 does? It actually introduces this concept of bundlers. So the bundlers will basically bundle transactions. They will aggregate transactions coming from smart accounts, and they will initiate those transactions on the blockchain. So they kind of initiate them on behalf of the smart accounts. It's not a perfect solution, but I would say it's a smart workaround. It works pretty well, and so it kind of solves this first issue. What ERC-4337 does not do is solving the other issues we have with Ethereum, right? And that's why zkSync Era is amazing. That's why it's an amazing tech, because in zkSync Era, you have a native embedded integration.
AW, I'm muting you.
Thanks. And so that means basically that on zkSync Era, EOAs and smart accounts can initiate transactions, and they are basically equal. As you know, zkSync Era is much cheaper than Ethereum. And then finally, smart accounts are first-class citizens. So transactions coming from smart accounts and transactions coming from EOAs will follow the same flow on zkSync Era, and so developers only have to build for that flow. Now, zkSync Era, as you know, is pretty young, right? It's been live, at least on mainnet, for only a few weeks. But I just want to go through a few examples to show you that account abstraction already is there, that there are use cases, that the tech is working, and that all we have to do now is basically take that tech and use it to build on zkSync Era, which is a perfect network to do so. So just going very, very quickly through a few examples. The first one is social recovery. That is a very wallet-focused example, of course. But I think this is very important because basically with social recovery, users don't have seed phrases anymore. They don't need them anymore. If they need to trigger a recovery process, they can use guardians. And so, I mean, from a user perspective, that is a much better user experience. That product, we already have it nowadays on Ethereum, and it's coming very soon to zkSync Era as well. What is very nice is that it remains fully custodian, so you keep custody of your assets with social recovery. Then Argent Shield, which is basically a 2FA. So because your account is a smart account, you can basically ask that for some kind, you can set it up in a way that for some kind of transactions, you will be required a second factor authentication, depending on, I don't know, like I would say what is deemed a critical transaction. Then there is the example of Multicall, very nice example as well. So Multicall, what it does is that it will bundle several transactions together, and it will simply call them at once. So the example that is here very well known is, of course, the ERC20 approval, right? When you want to swap an ERC20 token, you have two user actions. The first one is approve the token. The second one is swapping. So I would say that's pretty bad from a UX perspective. Thanks to Multicall, you can bundle all this in only a swap button, and it all happens at once. That is a very well-known example. I also want to show this one. So this is Aspect, which is a NFT platform on Starknet. And basically on Aspect, you can purchase different NFTs from different collections just using one buy button. So that's a very good experience, of course, from user perspective. We're going to have a small demo of Multicall later on as well in this session. Then, yeah, session keys, that's an example I love. What a session key is basically a key that will be signed by the user at the beginning of a gaming session. And the key will have the authorization to basically sign a set of transactions automatically. So here in the example we have here, it's Influence, which is an on-chain game. And in the session key, we have given the smart account the authorization to automatically sign, like scanning an asteroid, setting a name to this, giving a name to this asteroid, and building something on that asteroid. So there is no user action that is needed for each of these actions. And then, yeah, last example, I think this is a great example as well. That is actually an example on zkSync Era. So that is the paymaster. That's something that was used at ETH Denver. So if you went to ETH Denver, you could actually pay for your food at the food trucks with that Beetle token here. So you basically got airdropped 10 Beetle token, and then you could pay for your food. What is amazing here is that gas got abstracted away thanks to the paymaster. So as a user, you don't realize you are actually using the blockchain because you don't need ETH to pay for gas. You don't need gas. You don't even realize gas has been paid. The gas was simply sponsored by Matter Labs, and the UX is very, very smooth. So I just want to now spend maybe a few seconds on that sentence here, which says basically account abstraction combines Web3 magic and Web2 UX, right? Because everybody here in this session is convinced that Web3 is awesome, that it's magical, but now we need to convince the mass public that it's actually awesome. And you can only convince the mass public if the UX is as good as the UX they have on Web2, right? And that's what account abstraction does. So yeah, now I will maybe just checking if we don't have any questions on the chat. So yeah, not yet. Don't hesitate. I will now ask Axel to come on stage, and we are really gonna have this deep dive into the code and to see how we can make a dapp compatible with account abstraction.
So I see a question here about dapp compatibility issues for smart contract wallets. So depending on what you mean, and I'll get to this in a minute. The kind of recurring issues we have with smart contract wallets is that on Ethereum wasn't initially designed so that or with account abstraction in mind, so that where all accounts would be smart contracts. So many dapps, a lot of existing code kind of made that assumption and started doing things differently if the person initiating the transaction is a smart contract, because they were kind of assuming, oh, that's probably not a user, that's some kind of automation. And so since zkSync is EVM compatible, a lot of those incompatibilities that we have on L1 can translate to Era if people just copy paste old code or are not aware of these incompatibility issues with account abstraction. But yeah, since we're in a framework where this is much more center stage, that's also one of the points of this presentation, is to raise awareness about these issues. So yes, there can be incompatibility issues, and we're going to see in a minute what those are. Any other round of questions? You can unmute yourself and ask directly if you want to. Okay, cool. Then we can just continue. So we have documentation page here. It's docs.argent.xyz, and so it has a few different pages. Let me try to hide that. And here we have a section on Era that's also about a login SDK we have for Era. But if you scroll down a bit, we have a section on account abstraction and how it's a bit different regarding a few things. One of them being signature validation, that has to be done differently than from EOAs with smart accounts. And the other one is regarding this thing called transaction.origin. So for the first one, the difference is an account what account abstraction is it abstracts away a few things about the account. First, it's validation abstraction, meaning the account can define itself when and how a transaction is valid and should be executed. On Ethereum, a transaction is valid according to a few hard-coded rules, like if a single ECDSA signature is correct, if the nonce is incrementing, if the accounts has enough balance, and so on. When we abstract that, it means the app can code those rules itself. So regarding signatures, the account can define what kind of a different non-standard kind of signature for its account. Sorry, was that a question or is someone unmuted? I think it's a Lincoln. Lincoln, if you can mute yourself.
I don't have just listening.
Okay, can you just mute so there's no background noise? Thank you. Okay, so one of the biggest issues is a lot of dapps, a lot of code assume a signature is just going to be a single kind of ECDSA signature, where your account could be a multi-sig. It could, its signature could actually consist of multiple signatures. In the future, the signature could use a different cryptographic curve, meaning it could actually have been signed by something on your hardware security module on your phone that's using a different way of signing. So you can't really assume there's one way. So if we go into a bit of an example here, I assume most of you will be familiar with Solidity. In Solidity, the way we verify a signature is using something called EC recover. It takes one signature and gives you back, tells you who was the address, the account that signed it. But as we said, accounts could define their own logic for validating a transaction. So what you have to do instead is call a method on the account. This method is defined E1271, and you call this isValidSignature to know if this if a message is correct. So you gotta do it in two places, both in the smart contracts, you validate the signature by calling account, and in SDKs, in client-side code, where same way you have to call the smart contract, you have to make a read call to determine if the signature is correct. And another difference is this signature is only going to be valid it's valid the moment you call it, meaning the account could change its validation rules. It could decide to rotate one of its keys or something like this, and then a signature that was valid in the past wouldn't be anymore. So I'm gonna switch to a code example here. I have a simple smart contract, basically kind of authorizer for doing a swap. It takes in some swap data and the signature that's in this data parameter. And if the swap is deemed valid, it passes on and swap is executed. So in this data, we do some decoding to extract a signature, and then we validate this signature. And down is just below. It's pretty short smart contract. We're doing this standard decoding of parameters and calling EC recover and checking that the signature, the address recovered from the signature belongs to some kind of hard-coded owner in the smart contract. But now let's say instead of this hard-coded address, in a world of account abstraction, it could be a specific account. It could be, assume this is some kind of vault, and multiple people have to agree to do this swap or something like that. So we're gonna edit this code. We're gonna do an update to make it work with EIP 1271. So it turns out OpenZeppelin provides a great library for doing this. Let me just move things around here on my screen. So it's called signature checker.
Just a quick question from
Yeah.
my side. So the account contract should adhere to that interface, which is valid to be compatible with the signature. Is that right?
Yeah, that's what's called EIP 1271. It's like an interface on the account where you define this function here that takes the signature, message, and basically is basically a Boolean. It returns either true or false. Is this signature valid? And you can code this function whichever way you want. But this is really for the people who build accounts, who create smart accounts. The point of view we're taking here is more one of a dapp, one of infrastructure provider, someone doing regular smart contracts, and who just need to know how to verify the signature on an account.
Yeah, cool. Thank you.
No worries. So there is this utility. First, we can check this 12.1 if they have something for it here. I think they have an interface. You can see that 1271. They define this interface with just this function, and basically you want to call this function and check the return value to know if the signature is correct. But the thing is, both on EVM and on ERA, there are still non-account abstraction accounts, otherwise called EOAs, which obviously don't have this method. So you kind of have to branch, check, is it a smart account? If it is, yes, I'm calling this signature. If it's not, I'm still going to have to do EC recover the old way. So to avoid this complexity, OpenZeppelin did this other library called signature checker. And this is basically what it does very simply in a few lines. It works with both EOAs and smart accounts. So in my project here, I'm first gonna have to add the dependency. So this is a bit of a live testing. If I'm doing anything stupid or fumble a bit too much, don't hesitate to tell me what I'm doing wrong. So I have to install the dependency. More used to Yarn, but let's do it with NPM. I think it's OpenZeppelin/contract. Maybe I'm gonna do it. Anyone knows how to hide the Zoom status bar? It's a bit in the way. I'm just gonna put it below. Uh-oh. Jesus. Yeah.
Do you mean for zooming the code editor, Axel?
No, the bar with all the buttons with mute, start video, screen share. I never find a way to hide it, but it's fine. I'm just leaving it here. So I got my library. Basically, what we want to do now is remove this thing because it's wrong, and I want to replace this by the OpenZeppelin call. So let me just see how it's here. Let's check the import. Okay, they do have the import. Sometimes it's not super easy to find what you're looking for in the Open Zeppelin docs, but basically we have another import. Have a test here. Let's check if the import even works. It should recompile and call this is valid method. Well, actually it shouldn't because I have a comment here. So let's see the error. Cool. So now also here you can see the difference. Instead of just is valid signature, they added the now to really emphasize that the signature is valid at this point in time, but it may not be in the future. So I think we want to call this, and since it's on an address, the signer, the address we have is this master signer. The hash we just computed above here, hash of the message, and the signature we have also. So to use the library, is it using signature checker for address? And yeah, first maybe let me just show you that the test pass without this change. iPhone 11 Pro, did you have a question? Okay, so the test passed.
Can you mute Axel? I don't have the.
Am I the only one? Let me see.
Yeah.
iPhone 11 Pro, mute. That's a cool name. Okay, so the test passed. Now let's replace this with our signature checker. So it's on address. Our address should be this master signer. Uh-oh. We said it is valid signature now. And then the order of arguments. Then come, because I'm using it as a library, this one is the master signer, then hash and signature. Our hash is this one. Signature is above. And that's the difference. So let's see if I haven't made any mistakes. Oh, we have some warnings probably. Oh, cool. Worked on the first try. So cool. Yeah, that was it. That was pretty simple change. You add a library, you replace all that assembly, EC recover complications, makes your code simpler. It's actually just as efficient in the regular case. We can check if you want what this is valid signature now does. Can I actually just click here? Yeah. So what it tries a regular EC recover on the address. If it doesn't work, it uses this 1271 interface to call the is valid signature on this signer in this account contract, basically. And if that's correct, basically returns the correct value, it considers the the signature to be valid. So that's kind of the biggest thing to be thinking about when developing an app or something else. Whenever you have a user, an actual account person doing a trade, whenever you get a signature from them, you have to use this method instead of EC recover. You can make an exception if you're validating a signature for some infrastructure stuff, maybe an Oracle's giving you a signature or some backend where you know it's not a user, it's really just a signature coming from key that's not gonna hold funds, and then you kind of know it's always going to be one signature. Then it's okay to still use EC recover, but in a general case, this doesn't cost much to use that library, so it's a good habit to have.
And so, yeah, sorry, just interrupting. So that basically makes the dapp compatible with account abstraction, right?
Yeah.
So it's a matter of 15 minutes.
Yeah, I mean that's one of the aspects. Yeah, there's another one, but that's yeah, that's the important one. Any questions regarding that? Let me see the chat. Okay, cool.
Well,
Thanks.
good.
Okay, don't hesitate to interrupt me if you want. Another issue is what's called tx.origin. This is again because on EVM, on Ethereum L1, transactions can only originate from EOAs. Then smart accounts have to use tricks and use these relayers like Antoine mentioned before to send transactions. And a lot of dapps, like especially we've seen that with NFTs, sometimes they check on transaction origin and they just block every transaction where this TX origin is not an the message sender, if you're familiar, because when it's not, they assume someone's kind of automating or writing a script to mint all NFTs at the same time. So that's just not possible in a framework where user accounts are also smart contracts. So there are also plans to deprecate that from EVM. It's gonna take time, but it's a good habit to stop using it now. So yeah, so also just coming back to this signature validation, that there's two parts of it. There's one in the smart contract and one on the SDK. You also gotta check them differently on the client side. For example, we had a case with Uniswap where in some of their JavaScript library, they easily forgot that a signature could not be that. And here we had this example where they were taking a signature and parsing it in its way where it was assumed to be just an ECGSA, and that broke some flow. So usually, depending on what you're building on, the platform is going to give you a different library to validate the signature. In the case of Era, there's a function called a signature message correct, and that's just one. And this will same way behind the scenes check if it's a smart account and validate it this way, or do it the other way if it's not. Yeah, there's two methods, one for type data and one for the message signature. Yeah, this one. I think we're good for this first section. Antoine, do you want me to continue right away with the multi-call, or?
Yeah, actually we have a few questions that have arrived.
Oh, okay.
In the chat.
Indeed. So let me try to go up. Can we support regular accounts together with Argent A? Yeah, of course. That's seamless. Your dapp shouldn't do anything differently regarding if it's a smart account or an UA, as long as you follow these two recommendations. Maybe a third one we'll see soon. Everything works the same.
Yeah, something I think is worth mentioning as well is that what you just demoed is not Argent account abstraction. This is just to make your dapp compatible with any kind of account abstraction on zkSync Era. So that's because at the moment we are the biggest wallet using account abstraction, but I'm sure there will be plenty other wallets as well joining, and so just doing this, you will be compatible with all these wallets.
Yeah, and also if you're a multi-chain dapp or something else where on other chains it's people use 4337, these issues are the same. So you have to be aware of them here too. on Era it's native, so there's less to worry about. But imagine maybe you also want your Gnosis safe users to be able to use your dapp seamlessly. So that also applies to them. All accounts must have code, or what happens if addresses no EOAs don't have code? That's the idea. The question is more, you shouldn't do anything differently if the message sender has code or doesn't. Anyway, I think there's plans long-term EIPs upgrades to Ethereum to disallow this introspection anyway. So dapps won't really be able to tell if an account has code or no in the long time in the future. Are EOAs able to perform complex logic on Era like 3074? I don't even know what 3074 is, at least not, not at the top of my head. Let me see. Oh, I think this is an older try at account abstraction that wasn't, we didn't really decide to go through with it. I think I actually was at the presentation of this at EFCC by Ansgar. But at least on Era, it's been made natively into the protocol. It's like an advanced version of this, if you want. And yeah, EOAs can also use a lot of the improvements to the protocol that are made instead of on EVM where they can't. Like, for example, on Era, there's paymasters on Era. EOAs can use paymasters too, whereas with the 4337, I don't think they can. So yeah, it's that's a great point. There should be no more EOAs long term. That would be the ideal. That's the end game account abstraction. Today, they're still both on Ethereum and Era. It's kind of not an ideal state of situation because it creates differences, but long term the goal would be for each EOA to upgrade to a smart account, because it is much nicer when you're on a chain where all the accounts, no exception, are all smart accounts. Devs kind of have to accept this different mentality and way of building. But at least, yeah, with Era, with native account abstraction, it's easier to get there. Yeah, thanks for the docs. Cool. Antoine, are we ready?
Yeah, so I think now the goal would be to demo how to implement multi-call, which is a quite actually basic use case of account abstraction, right?
Yeah, that's a nice feature you get with account abstraction that we call multi-call, which allows you to send multiple transactions at the same time. And this one on Ethereum, you don't get it for EOAs. So we've implemented it in the Argent accounts as a special method. And doing that, you can solve, I assume a lot of you use DeFi, and I use it too. And even like just yesterday, the annoyance of having to approve every single token when you when you do a swap, when you add liquidity. All these things should just be done, but all these multiple transactions should be bundled into like a batch and sent to be signed as a single message. And that's what multi-call enables. It improves user experience a lot. And it's especially important for newcomers to DeFi. I heard this story of someone trying like Uniswap for the first time, and when they clicked on approve their token for the first transaction, they thought that was it, and they were waiting. Where's my swap? Why is it not happening? They didn't understand. They have to click twice. So it's pretty bad. And so since we at Argent, we actually support this on Ethereum L1 too, and we re-implemented it on. Oh, that's not up to date. We re-implemented it on Era. So we actually made a library and an SDK that allows you to send multiple transactions in one go. Because again, as a dapp, you want to be compatible with everyone. And since EOAs don't support it, you want to have some kind of a backwards compatibility. So what we did is we have this SDK where you can list in an array all the transactions you want to bundle and send as a single one if the account supports it. So here we're adding liquidity to a pool, we're adding DAI and USDC, and then sending all that as one. Actually, so I actually have a demo here. I have an app. So this is very simple dapp. I can log in with MetaMask, or I can log in with a smart account like Argent. Let's try with MetaMask. I should be here. I should have some tokens. I have some USDC and simulating some kind of liquidity pool where I'm adding one of each token. So is my MetaMask open? Connected, should be. Imagine this is some real dapp. I'm clicking here, add liquidity to the pool. Let me hide that. Oh, sorry. First thing is asking me to approve to use some of my DAI. So I could be tempted to use some kind of very high number. In real dapps, usually when you click one of those, the default, it's some super high maximum number. Here, I could still be tempted to not be bothered too much, and you in the future, so use some kind of a high approval. Ask improved on that recently, but it wasn't that great in the past. First transaction goes through. Why is it in a queue? Wait, did I not approve? Yeah. Oh, that was USDC. Okay, so that's the second transaction, I guess. Oh, that changed. So now, interesting. Yeah, when I tried yesterday, MetaMask popped 3 times. And so here I'm again. I don't have enough ETH. Oh, that's inconvenient. How is this possible? I mean, how can it be that? I think the testnet became really expensive. Oh, that's too bad. Does anyone have a bit of testnet ETH to send here? Otherwise, I can try to bridge, but I hope it's not going to be too long.
Axel, people can send you some in the chat.
Oh, cool. That's the address. Isn't just a little. Things seem a little slow. Oh, okay, portal. Try to read. Oh, it was a minute. Okay. Always check you have enough ETH before the demo. That's what we call the demo issues. So, yeah, that's pretty low. That was the one. Anyway, that stopped in the middle. Let me do it again. Okay, so because there was something weird with the MetaMask popping up. So this is a sequence of 3 transactions. I'm doing 2 approves, approving DAI. Then I'm approving USDC, which once the DAI transaction is confirmed, it opens up again. It asks me to approve for the USDC. Again, I'm lazy, I'm putting a large amount because I don't want to do this in the future, which is grossly insecure, but it's to prove a point. Anyways, testnet tokens. And now the actual transaction, MetaMask pops up a 3rd time, and I still don't have enough ETH. That's super annoying. But anyway, I think you got the point. If I had had enough ETH, should we wait just a little bit? I thought the bridging would have gone through at this time. Anyway,
drop the wallet address on the chat. I can send you like 1 ETH now.
I think I did. It's here just above. Oh, girly gas is really expensive, but I think it's fine. I got my point. Here you see that using this SDK, this is MetaMask, so it had to send 2 transactions. Usually there's 3 because there's the final deposit in the pool. I had to reject it, so there's only 2. And this is for an EUA, so it sends these, and you get back all the receipts of the transaction. Anyway, you saw this MetaMask pop up many times. It's super confusing, especially for new users. So let's see now how it works with multi-call. So this time I'm gonna log in with Argent. When I do that, it doesn't pop up MetaMask, but it shows this QR code and asks me to log in with my phone. Instead of actually using my phone here for demo purposes or more like dev purposes, I have a command line tool, which this is like a phone. It scans the screen for the QR code, and if it finds ones, it asks me if I want to connect. So this is my wallet. Imagine it's a phone. Click yes. I approve connection from my wallet, and here I have another account, the one on my phone. Ooh, I'm really low on the tokens, but I'm gonna do the same thing. I have no allowance on the pool. I have to approve both of those and then do the transaction. This time it's using the same code as before, but it detects it's an Argent account. When we do that, I click the button. It asked me to approve it on my phone, and on my phone here, I would get a nice notification asking me, do you want to do this? It's actually 3 transactions. It would show me here. There's 2. The dapp wants to use 2 of your tokens, DAI and USDC, and then it wants to add the liquidity. Yes or no? Okay, I'm gonna click yes to approve this, and it's doing it remotely. There are some delays. And then, okay, all that is done. And now you can see here, there's only one link. So it was done using only one transaction. You can see I had one USDC, it was deducted here. And only one action in the wallet. That's way better user experience. So yeah, that's the SDK. That's how you can use it today. You just basically build the list of transactions, you send them, and it's still backwards compatible with MetaMask and UAs. Otherwise, you'd have to send them separately and update the UI. So if that's something you're interested in using, let us know. That'd be interesting. You can contact us. There's an address here, or you can hit up the Discord. Yeah, that's the tool.
I have, thanks for the demo. I have several questions regarding this part. In the zkSync kind of abstraction, since it supports it in the protocol level, I believe it's not a user operation mempool like 4337. Is there like a separate mempool for a transaction before data gets mined, or?
It's native account abstraction. It's not 4337 account abstraction. So it's just a regular transaction that originates from a smart contract.
Okay, yeah. And then the second question I had was like, in regards to MEV, like if users tend to use the bundled transaction, it means that like a bundle of several transactions, what the user will do will be in the mempool. Does that somehow enlarge the attack vector for MEV compared to ordinary transaction where only a single transaction is in the mempool?
I mean, it's not different than any non-account abstraction transactions in the mempool.
Yeah, but it uploads, let's say like 5, right? Then it means like MEV bots can analyze them. I just wanted like your opinion or like how you think about that.
So I'm not sure if there's, like I said, if there's any difference with non-AA transactions. Also, this is on layer 2, so there are different considerations regarding MEV because the set of people having access to the sequencer mempools is going to be much smaller. And I'm not super familiar with that. Maybe someone else from Matter Labs can also answer, but on the sequencer, you probably don't have exactly the same MEV opportunities because I'm not sure if you can do the same kinds of attacks anyway. But I assume what you're saying is on with the bundler, your user op is more hidden from MEV bots, whereas here they're not. Is that what you meant?
Like what I meant was if they use a bundled transaction like the multi-call, then like they put, let's say in here, they put 3 transactions in a single call. It means the MEV bots can identify 3 of them. So I was just thinking that the user might be more vulnerable to the MEV bots because it's 3 rather than 1 compared to ordinary ones.
Good point. I actually don't know, but in this case, I mean, the simple approve doesn't change anything to the MEV opportunity. So
yeah, that's right.
So it doesn't change much in this example. And anyway, these 3 transactions are bundled in a single transaction in this multi-call framework if supported. So in the end, it's really the same thing as sending the final transaction with the approvals already done, basically. Oh yeah, and something I didn't mention is when you have to do these approvals separately, because you don't want to do them later too much, you tend to put a big one. Whereas in this case, you don't have lingering approvals like we saw. I think it was this weekend with SushiSwap having a vulnerability, and all the open approvals were vulnerable. In this case, you can always approve just the exact amount you need and don't keep anything open. And it's not a hindrance on user experience. What happens if one of the transactions fails? The whole transaction fails. Yeah, all of them get reverted. It's a good point. It could be configured in a different way where you do want to try and continue on. In this framework, it doesn't, because it's like if your approval fails, usually want the swap to fail. It's really thought for this use case. Yeah, so the whole multi-call is atomic, basically.
Yeah, we still have plenty of time, so please shoot your questions if you still have some.
When do you guys plan to support session keys type functionalities?
On Era, it's planned, but it's not ongoing, so that'll come at some point in the future.
Got it. And what about a multi-sig?
If your question is for Era, that's Gnosis Safe is really the go-to multi-sig. I'm not sure how advanced they are on their plans, but we don't have plans to make a competitor to Gnosis Sig. Gnosis
Got
Safe.
it. Yeah, they haven't published any specific date, so right, so it's still there. Is there any other solutions that is out there today that people are using for multi-sig?
Out there already? I don't think so.
Okay.
We have a response from Ramon saying Gnosis should be available soon, something like a month.
Oh, cool.
Sorry if we're having too many questions, but you shared that MetaMask already supports this kind of multi-call, and I think this is available because it's like also the same ECDSA transaction, but I think the main difference could be like, are they able to show the user that this single sign actually does 2 approval and 1 add liquidity?
So
Right?
no,
So like,
no, MetaMask doesn't support multi-call. That's why I don't know if it was super clear in my demo, but MetaMask popped 3 times and I had to do 3 transactions.
yeah, but Argent just once, right?
Yeah.
Okay. So does Argent have like a UX to somehow show them that this single signing or confirmation is doing 2 approvals and 1 deposit pair?
Yeah, exactly. That's the point. It'll tell you here you're actually signing 3 transactions in one go, and this is what they're doing.
Okay. Yeah. Thank you.
No worries. Interesting question about the build token. Is it the one used at ETH Denver, or am I mixing things up?
Yeah, it's that one, yes.
Yeah, actually, a bit of trivia here. At ETH Denver, the app they initially built was not compatible with account abstraction, and because they used to validate a single signature. But then we asked them to make it compatible, and so they implemented EIP 1271, and then it worked with smart accounts too. Yes, Alamin, if you're interested in seeing more, you can see this website here. It's just docs.argent.xyz, and then most of what we talked about was in this zkSync era section. Have to scroll down it and you arrive on the account abstraction support. We'll probably reorganize this so it's more easily findable. So Benjamin, can we add some custom logic to transaction verifying? Depends on your point of view. What are you doing? Are you building a dapp or are you building an account?
I thought about account.
If you're building an account, yeah, that's the whole point of account abstraction is there's validation abstraction in addition to nonce abstraction and guest abstraction and stuff like that. But validation abstraction means you can code yourself the function that decides if a transaction that wants to be sent by this account is valid or no. So
first of all, I need to deploy some wallet account contract to blockchain, and then use this custom logic. Is it right?
Yeah.
Okay.
Well, depending on the chain, on the framework, there's going to be a different way to do it. On Era, you have to use the Era's custom account framework. If you're on another chain, you may be using EIP 4337, which is a bit different. So they will each tell you how to define your validation logic. Same thing for value transfers. It's always the same validation logic, whatever you do. If it's a value transfer, if it's a dapp call, if it's anything else. You could do something differently for value transfers, but usually you want it to be the same logic for all transactions. It's a single ECDSA for EOAs, but another account may define something else. It may not be ECDSA, maybe another curve. So maybe for some who join late, what you have to do is use EIP 1271 and call a method on the account to determine if a signature is correct, instead of doing a single ECDSA.
On the question of docs, the current docs seems very geared towards like a developer. Do you have plans to have docs that are retail user facing?
Yes, but I mean, depends. What do you mean by retail?
Like how to, set up an account on Era and how does it work and something along those lines.
So yes, but we're not released. We're not rolled out yet. That'll come progressively. So the Argent account today is not open for retail, but when it is, of course, it's not going to be dev focused. We're preparing first all the developer support to prepare for the retail opening and to ensure that this rollout is as smooth as possible on all dapps.
Do you have any ETA for when that would be, when it's more broadly available?
We have to complete our audit first, which is ongoing. That may take a few more weeks, and then it's going to be progressive. First to some partners and dapps, depending on who you are. If you are already building a dapp on Era, we may give you an early access, but full launch to everyone is going to be progressive.
Got it.
Then there is a question from David. Maybe I can take this one. So how widely adopted is EIP 1271 in account contracts? So I mean, basically on Era, I mean, the account abstraction is one of the big value propositions of Era, right? So the idea is that all dapps will then be compatible at some point. And I would say that so far, many of them are already compatible. As you could see today, it's actually pretty easy to make your dapp compatible. So I mean, it takes a matter of 30 minutes to be compatible. So normally on Era, it's going to be widely used.
It's also going to be easier on Era since there's already a lot of tools and facilities built around this.
Yeah, we can still take a few more questions. Please don't hesitate. So in Argent's approach, are those operations in multiple signed separately or just for users confirmation?
No, they're signed. They're bundled. Sorry, in a single transaction, and that single transaction is signed. So from the point of view of the protocol, everything else is just one transaction. Also, it's like a simple interface. It's just a single multi-call method that other accounts could adopt. If you're building an account on Era, you just need
another
method. Yes.
silly question, maybe. Is there a way to build a session key type logic on the dapp and then Argent just approves it?
Well, no, because the Argent account wouldn't validate that transaction. That logic has to be built into the account, and that's actually separately something we're building on another chain on Starknet, where we designed this as kind of a plugin system, where as a user you have your account and you can choose different plugins to add to the account. One of them being this session key, and if you add that session key plugin, dapps then would be able to open those sessions.
Gotcha.
All good. Yeah, let's maybe just take back the screen sharing here. So if you have any more questions that pop up, don't hesitate either to reach out to Argent or to Mother Labs, and we'll be happy to help. There is just maybe a last slide that I would like to go through, and this is probably going to answer some of Robin's question as well. So at the moment we do have Argent on Era on mainnet, so it's up and running. But we are releasing actually the access very slowly. So there is a join list. There is a wait list, sorry, that you can actually join by scanning the QR code that is there on the slides. As Axel said, if you are building on Era, we are very anxious that to make sure that Argent's users will be able to connect and to use your dapp. We'll be very happy to fast track your access to the wallet, to basically put you on top of the waitlist. So again, don't hesitate to ask for that. And then, yeah, basically that's it for today. So, well, thanks a lot for joining. And I hope we will be able to stay in touch and to build together on zkSync Era, which is an amazing tech. I will maybe just come back on the first slide where you have our contact info here for those who join a bit later. So there you have everything you need to contact us. So thanks a lot and have a good day.